Welcome to this lecture. I'm Tony Symes. I organise monthly lectures for the Herschel Society. And the title of tonight's lecture is Creatures of Reason, John Herschel and the Invention of Science. And the lecturer is Dr. Stephen Case, who is in Illinois, near Chicago. The Herschel Society holds its lectures here with the support of the Bath Royal Literary and Scientific Institution. And we bring together like-minded people who are interested both in modern astronomy and the historical contribution of the extraordinary Herschel family. And we welcome new members. And Stephen Case is a historian of science and professor in the Department of Chemistry and Geosciences at Olivet Nazarene University in Illinois. He's written about Sir John Herschel previously and is the co-editor of the Cambridge Companion to John Herschel. Tonight's lecture will be based on his most recent book with the same title, Creatures of Reason, John Herschel and the Invention of Science. Over to Steve.
Thank you, Tony. And I just want to confirm, you can hear me well. My volume level is good. I'm going to assume that's a yes.
Yes, we can hear you well.
Excellent, thank you. So yeah, thank you for having me. It's an honor to be back virtually at the Brilsey, and I'm very happy to spend some time talking about a favorite topic of mine, which is John Herschel. So I'm going to begin with a quote. This is a quote from an editor. "There is no doubt in my mind," his excited editor assured him, "that its publication will create a greater sensation in these countries and elsewhere than any scientific work which has ever appeared." Unfortunately, that was not my editor giving those comments. That was the editor Dionysius Lardner, who was John Herschel's editor. He was the editor and publisher who would shortly release Herschel's Preliminary Discourse on the Study of Natural Philosophy. And Lardner had reasons to be optimistic that it would be a huge success. His author, Herschel, was one of the best-known scientific personalities of the day. Herschel was an active member of the Royal Society, from which he had received the prestigious Copley Medal. He was a founding member of the Astronomical Society of London, soon to become the Royal Astronomical Society. He had been a gifted student at Cambridge, coming in top in all of his exams. And he was a world traveler, mixing with the scientific elites of France, Italy, and Germany. And on top of all of this, his name was, of course, inextricably linked to astronomical fame. In some quarters, the planet we call Uranus was at this time still known as Herschel, after its discoverer, John's father. So yes, Lardner had reason to believe the book that Herschel was hastening to finish in the final months of 1830 would indeed be a great sensation. Now, fortunately for Lardner, his prediction was correct. When Herschel's Preliminary Discourse was published at the beginning of 1831, it indeed met with popular and critical acclaim, as well as financial success. As modern historian Jim Seckert has shown, the book sold especially well among middle-class readers, a growing reading public looking to better themselves socially through reading scientific texts. And this was exactly the point of Herschel's work. He wanted to show the public how science was done. If society was going to improve and to become more scientifically literate, more reasonable, and more advanced, then it would be by understanding the methods of science. Herschel would use this book to show how scientific theories, which he poetically called creatures of reason rather than sense, were created. The London Times outlined the popular appeal of the Preliminary Discourse soon after its publication. Herschel's book, it said, rendered the practice of science intelligible to the general reader, bringing it down from that region of clouds and mist in which it is often concealed from the eyes. But it also shaped the practice of science itself by influencing those who would in the next generation be called scientists. Charles Darwin, for instance, said that few books ever made such an impact on me. On reading it the first time, he wrote to a friend, "If you had not read Herschel in Lardner's Cyclopedia, read it directly." Michael Faraday, the pioneer of electromagnetism, said that he continually endeavored to think of that book and to reason and investigate according to the principles there laid down. Not only did reading Herschel's book, Faraday said, make him a better reasoner and even experimenter, but it altogether heightened my character. Another contemporary writer called Herschel's work the finest work of philosophical genius of the age. Now, much has been written on the importance of the preliminary discourse for the history of science. Philosophers of science still debate the fine details of the scientific methodology that Herschel outlined in the work and how it built on and expanded on the earlier work of Francis Bacon, who's featured on the frontispiece of the book. I'm more interested in how the book came to be, and that's the story I'll be outlining for us tonight. How did Herschel become the person? How did he fashion himself to be the person who would write the seminal work of modern scientific method, in a sense, the first modern scientific primer? Besides helping shed light on the life of the leading British natural philosopher of the 19th century, this talk will also show how Herschel's preliminary discourse was a work of reform. Herschel wanted to reform how science was done in Britain, and after a series of defeats, the discourse was his ultimate victory. Now, before I outline my plan for this talk, let me take a step back for just a moment. I first met the work of Herschel, John Herschel, as a graduate student at the University of Notre Dame, where I studied under the historian of astronomy, Michael Crow. I had heard about John Herschel before, but usually always in the context of the work of his father, William Herschel. John was often a footnote in William's work, the person who completed or extended William's work to the Southern Hemisphere. But as I began to investigate a specific question that Michael had about John Herschel's work on double stars, I realized that John Herschel did much more than just continue his father's work. In short, John established the sidereal revolution that his father and his Aunt Caroline had begun. His astronomical work, which we'll touch on briefly tonight, made the stars physical in the generation before astrophysics. And this became the topic of my dissertation, which expanded into my first book, Making Stars Physical, the Astronomy of Sir John Herschel. And what I soon realized, though, was that astronomy was simply one thread of what Herschel was involved in. He pursued work in mathematics, physics, chemistry, photography, optics, and geology, to say nothing of his influence in politics and his philosophy of science. These various threads were the basis of my second book on Herschel, which was mentioned earlier, the Cambridge Companion to John Herschel, which I co-edited, and which drew many of the contributing authors here to the Brillsea 2 summers ago for a day-long public conference on the multifaceted legacy of John Herschel. But I started to wonder what it would look like to write a scientific biography of Herschel. There are at least 2 biographies of Herschel's out there, but both of them are, in some sense, surveys. They don't really dive into the details of his life and his scientific legacy. So a scientific biography of Herschel would be a huge task, as Herschel's career covered such a wide range of topics. He was in many ways, and as we titled the conference from 2 summers ago, the last great polymath, the last of the generation in which natural philosophers could be well-versed in all the areas of natural science. But I soon realized that in any story of Herschel's life, the preliminary discourse would loom large. And so as I began my third Herschel book, I wanted to do 2 things. I wanted to tell the story of Herschel's early life, his childhood, his student years, his rise to scientific prominence. And in that sense, it would be possibly the first volume of a scientific biography. But I also wanted to answer the question that I started with at the beginning of this talk. How did Herschel become the person who could write the preliminary discourse? And what would that tell us about how we should understand that very pivotal text? So that's a story that I'll try to tell tonight, or at least give the highlights reel of. And I've broken this talk into a few chapters, which don't necessarily correspond to the chapters in my book. So we'll start with some background on Herschel's astronomical practice, but we'll center it on his remarkable aunt rather than his famous father. And we'll then talk about how Herschel got his start as a radical reformer, attempting to bring mathematical reform to Cambridge as a student. We'll then see how Herschel took his reforming spirit to London and put it to work in the formation of the Astronomical Society. Then, in the wake of the Napoleonic Wars, we'll follow Herschel on a few of his European tours and see how he established himself as a globally recognized scientific savant. And then finally, we'll look at the immediate background of the composition of the preliminary discourse and Herschel's failed attempt to reform the Royal Society itself. So, in 1824, 2 years after his father's death, Herschel was a young man of 32 and traveled to Europe to spend several months on his own personal grand tour. At the French border, his luggage, which would have included lots of delicate scientific instruments like thermometers, barometers, as well as the actinometer of his own creation, and that was a device for measuring the intensity of solar radiation, his luggage was held for inspection. When the customs officer saw the name on his passport, however, he declared, "That's the name of a planet, not a person," and let him pass without inspection. All across the continent, Herschel's family name opened doors. He would show up at the doorstep of observatories without introduction and immediately be greeted as an old friend or a recognized authority. John Herschel was born in the shadow of the telescope, and his family's fame shaped his entire early career. Now, the influence of his father, William Herschel, is obvious. So tonight, like I said, I'd like to highlight Herschel not as the son of William, but as the nephew of Caroline. John indeed learned how to observe from his father, but he learned how to turn those observations into useful data from his aunt. It was Caroline Herschel who calculated, reduced, and organized her brother's observations. And she continued this project even after William's death in 1822 and her retirement to her German home of Hanover. When John Herschel began his own astronomical work, revisiting all his father's double stars and nebulae observations, it was using the instruments and the observational techniques of his father, certainly, but just as important were the organizational structures and the catalogs that Caroline had constructed. The goal of John's astronomy was the same as Caroline's had been, to make his father's observations useful. As long as William's observations were the single observations of an amateur with a uniquely large and powerful telescopes, those observations were not useful capital for other astronomers. Though they included hundreds of new objects, William's catalog did not provide the accuracy for other observers to find these objects easily, which was becoming important as larger telescopes were constructed that rivaled William's. In addition, William's catalogs lacked standardized descriptions that allowed or that would allow later observers to measure signs of change in these objects, which was important if the observations of nebulae and star clusters were to provide evidence for dynamic change in the heavens. John's goal was to establish the sidereal revolution his father had begun, and he did this with his father's instruments, but with his aunt's organizational tools. So when William Herschel died, John decided to forego his original plans of practicing law to take his place at the telescope. He had previously revisited all his father's double star observations, but the hundreds of nebulae William had discovered still waited. Tackling them would be a daunting task, and here Caroline was the deciding factor. From her retirement in Hanover, Caroline worked to organize all of William's nebula observations into a single combined catalog. In this, she was continuing the work she had done for William. In a speech awarding Caroline the gold medal of the Astronomical Society of London, the astronomer James South summed up her work. She it was who took the rough manuscripts to her cottage at the dawn of day and produced a fair copy of the night's work on the subsequent morning. She it was who planned the labor of each succeeding night. She it was who reduced every observation and made every calculation. She it was who arranged everything in systematic order. From Caroline, John learned that observing through the telescope was only half of the process of discovery. Now, a catalog combining all of William's nebulae observations would have been an excellent resource for observers, and John urged Caroline to publish this, but she refused. Caroline had spent the hundreds of hours compiling it for one purpose: to send it to John to form the basis of his own task of revisiting the nebula and repeating his father's sweeps. She sent it to him in the spring of 1825, and it was the encouragement that the young Herschel needed. When he finally published his first catalog of nebulae in 1833, and this is an illustration from it, he acknowledged, without this assistance, I question whether I should have had the courage to venture on the task. In the published catalog, John said that Caroline's catalog should be taken as the groundwork for my whole proceeding. Now, the success of John Herschel's approach was that he embodied both his father and his aunt. Throughout his astronomical career, which extended to his period at the Cape of Good Hope, and then the subsequent decade he spent preparing his Southern Hemisphere observations for publication, he married William's observational expertise with Caroline's dedication to present those observations in a reduced, organized, and useful manner. So then, by the time John began his preliminary discourse, he was an acknowledged astronomical authority, largely due no longer to the strength of his name alone, but to the merits of his own nebulae and double star catalogs, which were as much the legacy of his Aunt Caroline as his father, William. But at the start of the Michaelmas turn, in October of 1809, when John matriculated at St. John's College, Cambridge, This astronomical work was all still in the future. As a young man learning from both his father and his aunt, John had been tutored in the new mathematical methods of the continent, including the works of Laplace, Lagrange, Lacroix, and their analytical approach to physics. William, in particular, wanted John to have the mathematical competencies that he himself had lacked. What this meant, though, was that when John started at Cambridge, he was dismayed to find that the mathematics taught there were, in his opinion, backward and moribund. Mathematics in England, John came to feel, was hopelessly behind. For example, French mathematics had developed along the lines forged by Leibniz and used the differential calculus notations still used today. Cambridge, however, still used Newtonian fluxion calculus, which remained closely linked to geometric representation. Another college friend, Charles Babbage, felt the same way. Both Herschel and Babbage found they were studying from French textbooks rather than English. Eventually, this resulted in a spoof of the debates that were raging at Cambridge at this time about whether or not the Bible Society should provide Bibles with or without the commentary of the Book of Common Prayer. Similarly, Babbage decided Cambridge must have an analytical society devoted to bringing the pure gospel of continental mathematics to the benighted Cambridge masses. The joke soon became reality, with a club of mathematical enthusiasts led by Herschel and Babbage meeting monthly to promulgate their imported mathematical methods. The Analytical Society became John Herschel's first attempt at reform. Their goal was to shift the instruction of mathematics from the more geometrically based British approach to the more abstract basis for calculus developed in Europe. As Herschel made clear in papers published during this period, working algebraically instead of geometrically was simpler and more elegant. Even traditionally geometric concepts like sine and cosine, Herschel felt, were better expressed as algebraic operations. Herschel and his Analytical Society pursued their goal of reform by two routes. The first was to publish the papers that the members of the Analytical Society had shared at their monthly meetings. Unfortunately, it soon became apparent that the memoirs of the Analytical Society would in reality be the memoirs of Herschel and Babbage, as they were the only members who produced papers the group felt publishable. The memoirs would be Herschel's first major publication, and it was a flop. Though a masterpiece of typographical technology, and you can see this is a modern edition, but the cover sort of features an example of the kind of mathematics that they were doing. The printers had to obtain special symbols for all the subscripts and the superscripts. At times, the equations were printed landscape instead of portrait, so that they would all fit on the same page. So even though, again, people said, or his colleagues thought it was a masterpiece of typographical technology, the new mathematics gained few adherents. Herschel complained that there is little or no taste for these things afloat. The maths are not here, as on the continent, considered as a branch of elegant literature. Now, if the memoirs was a failure, and one friend mused that there was not one person in a million who could actually understand it, the Analytical Society's second attempt, reforming the teaching of mathematics in Cambridge by introducing questions that required this new mathematics on the final exams, fared no better. William Whewell, a friend and ally, confided to Herschel that the inclusion of analysis in the exams had been a failure. Herschel's associates, Whewell complained, had stripped analysis of its application and turned it naked among the students, who did not understand it or see how it was useful. Mathematics, divorced from any real-world application, operating simply as a system of logical rules, was a bit ahead of its time, it seemed. It would be years before the seeds Herschel and his friends planted would bear fruit and transform Cambridge into a mathematical powerhouse. The Analytical Society dispersed, and the mathematical reform that Herschel had hoped to bring about did not materialize. Yet, this failure gave Herschel the experience needed for his later, more successful attempts at reform. Meanwhile, however, Herschel graduated from Cambridge with high honors and continued his own mathematical work. Like his father, he was made a Fellow of the Royal Society, the most prestigious group of natural philosophers and gentlemen amateurs in Britain. Herschel moved to London, where he began to study law. At the same time, the movement for political reform, which aimed to reduce the power of the aristocracy and open the voting franchise to more of the male population, started to gain steam. Herschel himself was a moderate reformer when it came to politics, But political reform and scientific reform would soon run along parallel channels, especially when it came to challenging the autocratic rule of the Royal Society. Now, one person especially frustrated with the Royal Society during this period was Francis Bailey. Bailey was an example of a new kind of amateur that was arising during this period, a self-made middle-class businessman. A stockbroker, Bailey had made his fortune early and retired to pursue his interest in astronomy. Yet, Bailey's pursuit was not the astronomy of gazing through telescopes. Instead, Bailey was interested in calculating star positions from historical star catalogs, like Caroline Herschel performing the complex reductions that made raw observational data useful. Ultimately, Bailey would reduce and publish data from star catalogs of Tycho Brahe and Ptolemy and others, as well as going on to supervise star catalogs that contained first 10,000 stars and then a later catalog with over 47,000 individual stars. Now, initially, Bailey was frustrated by the Royal Society's lack of interest in his mathematical approach to astronomy. The Society at this time had a reputation of being disinterested in mathematics in favor of topics like botany and natural history. Bailey felt that an alternate society should be formed, one that would be made up of others who, like him, took a more calculational approach to astronomy. Herschel and Babbage were both approached, and in 1820 they joined Bailey as founding members of the Astronomical Society of London, eventually to become known as the Royal Astronomical Society. Now, the Astronomical Society allowed Herschel to combine his interests in mathematical analysis and astronomy. The tools of analysis could be applied to the stars, and the catalogs that resulted would be linked to the expanding commercial power of London. Precise star positions meant more efficient navigation, and more efficient navigation meant safer trade. There was a reason the Astronomical Society appealed to people like Babbage and Bailey, who made their fortunes through commercial enterprises like insurance and stockbroking. Herschel found himself among a group of London middle-class professionals, motivated by meritocracy, business acumen, and accountability, who applied their forms of mathematical bookkeeping to astronomy. In both their practice and their social status, most members were marginal to the culture of the Royal Society. Yet Herschel saw that this group had the resources and the energy to employ his mathematical reforms in the business of astronomy. The new society also helped Herschel expand his circle of influence beyond Britain. As the Society's first foreign secretary, Herschel was in charge of correspondence with astronomers across Europe, inviting them to join the Society and building a network to share and coordinate astronomical observations. London became a clearinghouse for astronomical data. The memoirs of the Astronomical Society, which the young society soon began publishing, saw far more success than the Analytical Society's memoirs. However, Joseph Banks, the autocratic and long-serving president of the Royal Society, was less than pleased with the new upstart society. Banks argued that rival scientific societies undermined the prestige and effectiveness of the Royal Society. Nevertheless, the Astronomical Society's membership continued to expand. Herschel had found a group of like-minded individuals united in their approach. The ideals of the failed Analytical Society gained new life in the Astronomical Society. And the Astronomical Society taught Herschel about the importance of coordinating observations, standardizing measurements, and building an international cooperation for the practice of science. Even as Herschel continued his own astronomical work, following the footsteps of his aunt and his father, and coordinating the work of astronomers across Europe, he remained interested in chemistry and physics, particularly the physics of light. Herschel attended lectures at the Royal Institute while he was in London, ostensibly studying law, watching as Humphrey Davy used the Institute's large voltaic pile to isolate new elements, although this is actually Michael Faraday in this picture. He turned his own apartment into a laboratory, much to his parents' frustration, who felt that he should be spending his time pursuing the law. Herschel was fascinated with polarized light and its interaction with different materials, using light as a tool for investigating the nature of matter. His mathematical pursuits, which had initially been divorced from any physical application, became married to his physical investigations. He began to believe he could use mathematics Biot and Francois Arago in France. His friend Whewell following Herschel's work wondered whether Herschel was untwisting light like whipcord and cross-examining every ray that passes within half a mile. Later, Herschel's work on light would result in the publication of an extended encyclopedia article, over 200 pages and published as its own volume, that was widely recognized as the most complete treatment of optics since Isaac Newton. Now, the young Herschel was eager to travel to the continent to work with other natural philosophers, specifically those working in France. There, Herschel saw an example of the sort of scientific endeavor he wanted to cultivate in his own country. Yet for most of Herschel's life, England and France had been at war. He had visited Paris as a child during a brief period of peace, where his father had an audience with Napoleon. But as a young savant, making his own way in the scientific world, Herschel was eager to travel again to Paris to meet the natural philosophers and mathematicians whose work he had been following so closely. He first traveled to Paris with Babbage in 1819 and 1821, and then again on his own as part of a more extended trip in 1824. On each occasion, he was impressed with the way that science was supported in France. The French Academy of Sciences was a formal body of the state, and the natural philosophers who worked there were state employees. Herschel could not help contrasting this with the state of things in England, where the Royal Society was officially nothing more than an advising body, and its members men of independent means with no official government support. In France, Herschel was exposed to a new way of organizing science in which privilege was replaced by professionalization. In the academy, natural philosophers were paid for full-time research. Positions were highly sought after, limited in number, and required scientific output. By contrast, London's Royal Society had a membership that had ballooned to several hundred by the time Herschel had joined it, and only a small minority of this number contributed scientifically. Compared to what Herschel found in Paris, the Royal Society was clearly in need of reform. Herschel also traveled to the Low Countries with his close friend James Graham in 1822, a trip that ended tragically, as Herschel was away from home when his father sickened and died. He also traveled to southern France to study the ancient volcanoes there, part of his enduring interest in geology. But his most extensive travel was the 6 months he spent in 1824, traveling from Paris through Italy, visiting sites of historic interest, as well as making contacts with far-flung observers, such as Piazzi and Palermo, home of the southernmost observatory in Europe. He climbed both Vesuvius and Etna, making careful camera lucida sketches along the way. He returned by way of Germany, where he called on the optician Joseph Fraunhofer and witnessed Fraunhofer's method of observing the spectra of stars. Now, these are some examples of his drawings, his camera lucida sketches, which I could talk a little bit about in the Q&A, but many of these are published for the first time in my book. Herschel's travels affected him in several ways. For one, they confirmed his belief that science was an international endeavor, that the practice of science transcended all national boundaries or barriers. Throughout his career, and in particular through his work in the Astronomical Society, Herschel worked to coordinate natural philosophers across boundaries. This would eventually extend to the growing British Empire as well, as Herschel eventually worked to coordinate Navy officers and colonial observers across the globe. Secondly, it cemented Herschel's belief that Earth could be understood as a global system. As historian of science Gregory Good has shown, Herschel's work built on that of Alexander Humboldt, who Herschel met in Paris, to use the tools of physical science to integrate everything from global climate patterns to tidal measurements to charting the Earth's magnetic field. Herschel was part of the first generation of natural philosophers who began thinking about global physical systems. He used mountains as laboratories for measuring solar radiation, and he used Britain's naval fleet as a means of integrating astronomical observations from both hemispheres. Finally, Herschel's travels established him as a worldwide scientific authority. As mentioned above, wherever he went, his name opened doors. But his in-person collaboration with people like Piazzi, Fraunhofer, Biot, and others made him the contact point for many European or colonial natural philosophers corresponding with the British scientific network. When Herschel ultimately decided to write his book about the nature of science itself, he would draw on his global experiences, and he would have a global audience. So, when the publisher Dionysius Lardner approached Herschel about writing a volume for his new cabinet encyclopedia. Herschel had returned from his travels, was a recognized scientific authority, and was beginning to settle down to family life. In March of 1829, he married Margaret Brodie Stewart, the daughter of a Scottish Presbyterian minister and Gaelic scholar. He was also beginning to distance himself from the scientific community in London, devoting more and more of his time to observing from home as he resumed his father's sweeps and, again thanks to the work of his Aunt Caroline, began his own immense nebulae catalog. After his experiences with the failed Analytical Society and the more successful Astronomical Society, after his travels, and in light of his growing suspicion that the Royal Society was in need of serious reform, he had decided that he could best serve science by withdrawing from the controversies that were beginning to stir the Royal Society. Controversies that, in some extent, were caused by his friends Babbage and James South. He wrote to Babbage in 1828, "I am perfectly sick of the life of a savant by profession, which leads to nothing but quarrels and misunderstandings, in which everyone's temper is soured and no one's real interests are advanced." Now, part of these frustrations were with friends like Babbage and the firebrand astronomer James South, whose feuding with the Royal Society caused Herschel no end of frustration. But part of this was also Herschel's issues with the Royal Society itself, which he felt was being governed in a way that ran contrary to the interests of science. When Joseph Banks died, Herschel had hoped that the society might have a new, less autocratic president. But despite his scientific credibility, the presidency of Humphrey Davy, Herschel felt, was not much better. When Davy resigned in 1827, Herschel was frustrated to learn that Society Vice President Davies Gilbert, conservative member of Parliament, was negotiating to induce Robert Peel, who would ultimately become the Prime Minister, to be the new Royal Society president. Gilbert hoped Peel would rescue the society from, quote, "the conflict of aristocracy and democratic opinion," end quote, that was playing out in the wider political stage. "I wish the Royal Society rescued from the latter," Gilbert told Peel. In other words, Gilbert was afraid that the Royal Society would become too democratic. Now, this kind of backroom dealing, Herschel believed, undermined the society's credibility. But for the time being, Herschel had given up on changing the society from within. Instead, Lardner's offer gave Herschel a chance to bring his views on the practice of science to a wider audience. Herschel was very interested in the opportunity for writing for a popular audience. The growth of the middle class, decreasing costs of print, increasing levels of literacy, and technological innovations such as the steam press had made for a burgeoning reading audience. Herschel had long expressed an interest in writing for a popular audience. He told Babbage as early as 1816 that he hoped to get money and reputation at the same time by writing popular articles. Now, Lardner's plan was for a series of books treating different scholarly topics, each written by a known expert in the field, and this would become Lardner's cabinet cyclopedia. He told Herschel that he was open to any topic that Herschel wanted to write on, and Herschel picked light. He would write a popular version of the detailed mathematical exposition he had provided in his 1824 work. Unfortunately, the publishers of that original work were not pleased with Herschel writing a competing work on the same topic for another publisher. So Herschel acquiesced to a switch of his topic to astronomy. But in the meantime, though, his publisher Lardner had had another brainstorm. Each sub-series of his encyclopedia would start with an extended preliminary discourse, an extended essay on that field. And Herschel was the ideal candidate to write the preliminary discourse on the study of natural philosophy. So Herschel agreed and got to work. However, events in London soon made his writing especially poignant. Davies Gilbert, who had himself stepped into the presidency of the Royal Society when he could not convince Robert Peel to take the position, was planning to resign, and Herschel had it on good authority that Gilbert planned to pass the presidency to the Duke of Sussex, the king's brother. Not only would this confirm Herschel's fears that the Royal Society was an authoritative regime, with its presidency being passed on like a rotten borough, Herschel felt having royalty in the seat of authority was antithetical to science. How could one work objectively, he wondered, with a leader whose slightest suggestion could be taken as a command? So radical were Herschel's views on the So radical were Herschel's views on the egalitarian nature of science that he suggested the bookish Francis Bailey as the opposing candidate. Against aristocratic privilege, Herschel held up Bailey's singular, regular, methodical habit of business and his disposition to avail himself of talent wherever he can find it. In Herschel's view, Bailey's star catalogs and the scientific virtue they represented could stand against all the aristocratic privilege of the king's own brother. Of course, Herschel's reforming colleagues in the Royal Society knew that Bailey would not do. There was only one person whose scientific accomplishments and esteem could unify opposition to the Duke: Herschel himself. And so, in the final months of 1830, just as he was pushing to complete his preliminary discourse for Lardner's deadline, he was urged to let his name stand for the presidency of the Royal Society against the Dukes. He ultimately agreed, and soon the London newspapers were relishing the scandal of the Duke, son of the late King George III, being publicly opposed by the son of George's personal astronomer. Now, although it was a close race, the reforming coup failed. The Duke was elected, and the aristocratic party retained its grip on the society. But the crisis confirmed Herschel's belief that change was necessary, and the preliminary discourse was his method of bringing this to the public. In this respect, the discourse was Herschel's opportunity to set out his vision of science. Science, he argued, was larger than what took place in the halls of the aristocratic elite. More than a body of knowledge or a gentlemanly pastime, science was a matter of social and personal virtue. In the preliminary discourse, Herschel outlined the laws of scientific reasoning, providing a template for how investigators should search for law-like behavior in nature. But he also talked about how it changed you as a person, which again appealed to middle-class readers. The work was both the defense of the scientific life and a manual for constructing scientific theories. Outwardly, his reforms may have failed, but with the preliminary discourse, Herschel drew on his career, his connections, and his experiences to bring the ideals of science to the general public and articulate scientific methodology for a new generation. His work molded a generation's perception and helped shape the ideals of modern science. So as I bring this talk to a conclusion, I will end with a quote from Herschel himself. He says, "The practice of science would bring into exercise a sufficient quantity of sober thought that could then spread to social relations, legislature, and governance. When this happened," Herschel felt, "the condition of the whole human species shall be permanently bettered." And we can all hope for similar today. So with that, I've taken us through sort of not all of the details. Obviously, I go into a lot more detail in the book, but sort of some of the high points of what led Herschel to become the author who would write the preliminary discourse. And we have come full circle to what I discussed at the beginning about really how influential this book, his preliminary discourse, became in the history of science. So with that, I am very happy to open it up for questions. Happy to talk about the book, happy to talk about Herschel. Yes, thank you very much.
Thank you very much, Steve. If you're online, please can you type your question in the chat channel and we'll pick it up in a minute. And are there any questions in the room? Charles? Yes. Stand there, then you'll see you.
Steve, hi. Thanks, great talk. Just to go back to the preliminary discourse. I mean, I have read it, and it's actually, even for today's readers, really quite a fascinating thing. I mean, Victorian writers can be a bit turgid. They write long sentences, but I found it personally a fascinating survey, not only on why you do science, how you do science, but also science as known in Herschel's day. And because he includes a survey to all kinds of aspects of science, geology and chemistry and so on. And of course, it gives the picture of what was then known and explains it in terms of philosophy. And of course, that is not always how we know it. So it's, among other things, an amazing survey of scientific knowledge at the time. But I've got a sort of a rather more straightforward question. It's about surveying the sky. William quite quickly realized once he was doing his big sweeps with his 20-foot telescope, he needed a helper and recruited Caroline for that purpose. There's no sign that John ever did that. And he had obviously Maggie, his wife, and they cooperated on lots of things, not these wonderful pictures of flowers and so on. And I'm not aware of any sense that he tried to find an assistant, either through his wife or anybody else. Which is kind of curious because it must have been a very inefficient way of doing his observations. Any comment on that?
Yeah, I can comment briefly. I think you're absolutely right. He did bring along when he went, so shortly after the publication of the discourse, so a little bit beyond the time that I've talked about. And I do write about this in the book, sort of the final chapter of my book talks about what happens next in his life, right? And he does go to the Southern Hemisphere. He spends 4 years at the Cape of Good Hope. He disassembles the giant telescope, it ships it up and sails down there with it, rebuilds it. He does take along with him what he calls his mechanic, John Stone. And it appears as though John was there sort of helping with the actual movement and, your sort of running of the large telescope. But it doesn't seem like he had any sort of role in sort of recording his observations and reducing his data in the same way that Caroline did for William. And so it really does seem that for Herschel, for John, he sort of took ownership of that portion of the work as well. And I think it's part of what you had mentioned in it being inefficient. It does seem to have been fairly inefficient. It took him 10 years after he returned from the Cape of Good Hope to publish his Southern catalogs. And friends would urge him. They would say, get someone else to calculate for you. Get a calculator. But my sense is, and I don't have a place where I clearly see him saying this, but my sense is he really absorbed this from his aunt, that the reduction of the data, those calculations were part of the process. And he didn't really want to give that up, whether that was because he was picky or because he wanted, he had the most confidence in himself, or if just he saw it as part of the overall process. That seems to have been the case.
Right. Any more questions? So I've got one online comment which from Gordon, who's an excellent presentation, he says.
Thank you.
And so your question. Yes. Can you speak directly into?
Yeah, at the beginning, we talked about the age of the Renaissance, and I was looking in the library, and there was a book on the age of the Enlightenment. How do you think our own age will be remembered? I mean, on the one hand, you've got the age of technology, but what about the scientists of this age? Do you think they'll be given a special title to remember them by?
Are we talking, just so I'm clear, are we talking sort of the age that we're living in, or are we talking sort of the age that Herschel was working in?
Yeah, so
I apologize.
The age we're living in today.
Yes, okay. Boy, if I had to come up with it off the top of my head, as much as it pains me to say it, I think we might say something like the digital age, where, for instance, right, if we're just taking astronomical surveying, right, Herschel was, as far as we know, John Herschel was, as far as we know, the first and perhaps the only person who himself closely surveyed the entire visible heavens by eye. But within his lifetime, right, that's superseded by photography. And within our lifetime, that's been superseded by digital photography. So if we're talking about, for instance, the Vera Rubin Observatory in Chile, which is now online and is gathering terabytes of data every night. I was speaking with one of the research scientists there. They said the new discoveries in astronomy will be made by algorithm, right? They won't be things that humans see. They will be things that the computer recognizes in the patterns. And so I think if we had to give a label to this age, we might say the digital age. Whereas, with Herschel's period, the things he was seeing in South America, I'm sorry, in the Southern Hemisphere, for instance, he discovered hundreds of objects because no one had closely surveyed the sky, and those are things he's discovering, with his naked eye, or with his eye, with the telescope. And so, for instance, if you, like I do, have a Google alarm set up for any sort of news related to John Herschel, almost daily I'm getting, images of deep sky objects because the descriptions say, discovered originally by John Herschel. And that period is past, right? And now it's now I might label this the digital age, where discoveries are made that way. Good question.
Okay. Online, Gordon Houston says, was the Royal Astronomical Society formed after John's frustration with the Royal Society? You may have mentioned it earlier.
No, that's a good question, because I was kind of jumping back and forth in time in my presentation. It's a little bit more straightforward in my book. It came. The Astronomical Society of London was formed in 1820. And by this time, Herschel was a member of the Royal Society. And I don't think he was quite as frustrated by the Royal Society at that point as he would eventually become. In fact, you might trace some of the origin of his frustrations with the Royal Society to Joseph Banks' reaction against the founding of the Astronomical Society. I didn't mention this in my talk, but when the Astronomical Society was formed, they had recruited, I don't remember who it was off the top of my head, but they wanted a president who was a member of the aristocracy to give it some prestige. And someone had agreed to be the president of this new society until Joseph Banks said, no, I'm not happy with that. I don't think you should do that. And so then the Astronomical Society was sort of left without a president. And they finally had to lean on William Herschel, who said, sure, I'll do it as long as I don't have any responsibilities at all. But I would say sort of maybe that was kind of the origin. And then in the subsequent years, the next decade or so, I think his frustrations with the Royal Society grew and grew.
Yes.
Hello, Stephen. Thank you for the talk. Very interesting. I myself am an astronomy and space science student, so I was quite intrigued by the picture in the beginning with from Caroline Herschel, I assume, part of the catalog. And you mentioned just very briefly that there was a problem with classifying objects and things like that. Looking just at some of this picture, there seems to be like a mixture of potentially galaxies, big stars like nebulas and things like that. So I'm just curious how over the course of John's life and how, like, what method he used, or with classification, or how did you classify these objects, right? Like, how do you classify a galaxy from a star just by pure observation? It's so not easy. So I'm just curious the method, or sort of like the scientific, how it evolved effectively. That would be really interesting. Thank you.
Yeah, that's a great question. So I talk about this quite a bit, to a certain extent, in my first book, Making Stars Physical, because that's a huge question at the time, right? So William Herschel, and there's a similar story that plays out with double stars, but if we just focus on the nebulae, we don't know what these are at this point. They're smears of light, and so are they actually is it a luminous fluid? Is it a luminous fluid that is actually congealing into stars? Or are these clusters of stars that are so far distant that they appear as one object? So today, the things that William and John were looking at, we would classify as, well, some of those are star clusters, some of those are nebula, some of those are galaxies, and some of them are nebulae. But back then, nebulae was just a category for basically all fuzzy objects. And so William had seen many of these that no one had before. No one had he's finding hundreds of these objects in his surveys. The problem is, how do you classify them? How do you know what they are? And one of the thoughts was, well, if we could see that these things change over time, right? Like if we could actually see these sort of in the process of changing, then that would lend credence to the fact that it was some sort of luminous fluid that was maybe congealing. By the end of his life, or at one point in his lifetime, William really thought this is what they were, and he was seeing stars form. But it's really different. It's very difficult to get a baseline of, what these things actually look like if you're looking at them, before photography, because A, nobody else other than William has seen them with telescopes this size, and B, they could look different from night to night depending on the seeing conditions. So what John really wanted to do was he wanted to go back to all of his father's nebulae, and he wanted to sort of establish a baseline. So he was really interested in sort of describing them. He comes up with a classification scheme that he outlines in the Cape Results, which he publishes after his time at the Cape of Good Hope. And he is speculating on what they are, but he said, but what we first need to do is we just need to have a baseline of what these things look like in ideal viewing conditions, so that other observers can watch them over time and see how they change. And you see him, especially when he's in South Africa, really making these really elaborate drawings of nebula using Eta Carina, the Eta Carina Nebula. He spends a very long time doing this meticulous drawing, sort of trying to sketch out the nebulosity against the stars in the background, because again, this is all pre-photography. But he's trying to answer that exact question that you're getting at, like, how do we classify these things? And his first step is he's like, I got to go back to my father's observations, because William was seeing them, but he wasn't really doing a thorough job of sort of like classifying them, describing their characteristics. And again, Herschel was really interested in making drawings of them as well. Omar Nassim has a fantastic book called Observing by Hand. I'm looking on my shelf to see if that's, Observing by Hand, where he talks in detail about Herschel's method of drawing the nebulae. Good question, thank you.
Okay, we have some more questions online. So Duncan Steele asks, any idea why Herschel became a given name in the USA? For example, astronaut John Herschel Glenn and footballer diplomat Herschel Walker.
Yeah. The short answer, well, I'm not sure if this is the correct answer. I have talked to a colleague of mine who did his dissertation on Herschel's philosophy of science, had met, I believe it was the daughter of John Herschel Glenn, and asked straight up, like, why is John Herschel Glenn named Herschel Glenn? And that didn't seem to be it seemed to have just been a family name. That doesn't seem to have been a connection with our John Herschel, or at least to the level that was known then. But you do see Herschel's name turn up a lot. And in fact, the part of this is just because he was so well known. Surveyors and explorers who, especially lots of place names in Canada, are named after Herschel, and they are named after John Herschel, because he was, I tell people, he was like the Carl Sagan or the Stephen Hawking of Victorian England. My favorite place where you see this, if you've ever, I don't know if this is big in the UK, but over here, there's a backpack outfitting company called Herschel. So you'll see Herschel backpacks. And I always wondered what the connection was. Well, if you go to the Herschel backpack website, they are named after a town in Saskatchewan where the family originally came from. And that town in Saskatchewan is named after John Herschel. So in that sense, Herschel clothing is named after our John Herschel. But beyond that, I'm not really sure. I don't know all of the other ways that it sort of, I think it was just his prominence in the 1800s.
Okay, and we have a question. Was it frowned upon for British scientists to meet with Napoleon? Did Herschel face any backlash? Well, obviously the visits you mentioned in 1819, 1820, that's after the war. But
he
went earlier, didn't he, during a period of peace?
He went during the period of peace. And I'm not sure what sort of response William Herschel got at that period. Now, I've mentioned Joseph Banks, the president of the Royal Society, who was president of the Royal Society at the time. And famously, Joseph Banks he was meeting with some French natural philosopher during this period, and he got a little bit of heat for it. And he said something like, why should men of science care, right? Like, science is this international thing. A man of science is my brother, no matter what his nationality is. That said, the place where this sort of does come up in John Herschel's story is when he's a student at Cambridge. When he's a student at Cambridge, this is when, you know, Napoleon's invasion of England seems like it might actually happen. So anti-French feelings are sort of at their height. And then you have this young student saying, their mathematics is much better than ours. We need to be teaching the French mathematics here. And at that point, he did get a little, it was sort of frowned upon. Why would we want the French mathematics, right? Things that are French sort of seem anti-British. After the war, it seemed like there was really this drive to reestablish these connections in the scientific community that had been strained by the Napoleonic Wars. And so I think Herschel was sort of in the vanguard of sort of rebuilding these connections. I mentioned Alexander Humboldt as well. Alexander Humboldt wanted to study volcanoes just like Herschel did, but he had to go to South America because during the Napoleonic Wars, he couldn't travel to Italy. So when the wars were done, a lot of opportunities opened up for Herschel, and he capitalized on them.
And another question is the result of John and Caroline's work manifested in the NGC?
Yes.
Yes, that was
Yes.
that would have been my answer. Yes.
Yeah, so Herschel's general catalog was the basis of the new general catalog. So yeah, anytime you use an NGC number, you are building on the work of Caroline and John and William, but largely it was John.
Well, Charles and I learned about the work that Dreyer did in Armagh in Northern Ireland, which was a step from the Herschel's work towards the NGC. So, and Deepali asks, I read that John was responsible for developing photography. Is that right? Again, that's an easy question.
He, and this is something that comes up later in John's story, sort of after the period that I'm talking about, but during the period that I'm talking about, he makes a discovery that then later plays a pivotal role in the development of photography. So Herschel doesn't invent photography. He reads about the process, but what he realizes is that in his earlier chemical work, he has developed and I don't know enough about the photography, the chemistry of photography. If Kelly Wilder were here, she could answer this. She does a lot of work on the history of photography. But basically, the photographic fixer, the chemical that is sometimes used to be known as hypo, it was short for, I think, hyposulfate. He realized that it was what you would use to develop, actually to fix the photographic plates to keep them from developing further in light. And so he develops that method that becomes really the substance that is used in dark rooms up until photography, in my understanding, until photography is replaced by digital photography. And then he does do some photographic work. He's really interested specifically not using photography for like portraiture, although his portrait, I think, is the cover of the Cambridge Companion. His portrait is one of the earliest photographic portraits because he had colleagues who were very interested in this. But he's interested in using photography to study the sensitivity to light of different chemicals. He doesn't create the word photography, but he helps popularize it. And then he does coin the phrase snapshot and negative when talking about the photographic process. So he does loom very large in the history of photography. Yes.
Oh, great. Well, anyone who's interested in that might like to know that we're going to have an all-day conference on early photography, 12th of September, I think, next year. So,
oh, wow. All right.
Yeah. So if you come to that, you'll have an opportunity to learn all about it. Are there any more questions in the room?
How did Herschel respond to the discovery of Mercury? Not Mercury, Neptune, which was predicted by a mathematical understanding of the Newton's laws.
Yes.
Did he try to do other things in his own work?
Yeah, he actually landed himself in hot water with the discovery of Neptune. He put his foot in the middle of the controversy between Leverrier, the Frenchman who discovered, who predicted, and then directed the Berlin Observatory in the first observation of Neptune, and I'm going to blank on his name, the British astronomer Adam Couch, who was also searching for Neptune, but but he did not publish his results. So when Neptune was discovered, there was this whole controversy about what would we name it, because remember, Uranus didn't have an official name at this point. Some people were calling it Herschel. Some people were calling it the Georgium Sidus, which was what William Herschel called it after King George. Some people were calling it Herschel. And so now you have another planet ostensibly, well, it was discovered by the French. And at one point, Leverrier recommended calling it Leverrier. So there's this international controversy about what we're going to name these planets. And Herschel sort of ends up in the middle of it. And so I have a paper that I published, and then I published an essay as well that really talks about how Herschel got himself out of this mess of naming and nomenclature. And I argue that Herschel's really largely responsible for how we name objects in the outer solar system. And he primarily did this by his influence on how we would name the moons of the gas giants. But it sort of locked in, okay, it's going to be mythological names. So by the time that Neptune was discovered, Herschel wasn't really doing much of his own observation, but he was still a very well-known, prominent member of the scientific community. And so he got in the middle of this, unwittingly got into the middle of this international naming controversy. And then I argue sort of solved it and is largely responsible for how we name things in the solar system today.
Yes, Duncan Steele says the name that was missing is John Couch Adams.
Thank you. Yep, that's correct.
You mentioned the Herschel Supply Company, Steve. I've made 3 attempts to try and interest them in the man that their company is named after. I've tried it by social media. I've tried writing to them. I've tried banging on their door in Vancouver. And so far, alas, no shame, because they're very popular with 30-year-olds. They're a great audience for the Herschel story. But
yeah, I just want a free backpack.
It's good. I even got a gap with the backpack, but I can't persuade them to sort of take some interest in it and say, what lies behind this name they have.
Right.
Different point entirely. Steve, it's a great book, your book, and as you say, it's the sort of volume 1 of a biography. I know authors never like this kind of question, but can we look forward to a volume 2 at some stage?
I had so much fun writing this book. Herschel is such an interesting character. There are so many anecdotes and stories that are in this book that I didn't even mention in this talk. He has all these amazing scrapes as he's traveling through the Alps. He finds himself lost in the middle of the night on a glacier one night. And he also has these great journals where he's describing all this stuff. So there's all this material, there's all these letters, there's all these journals, and this book really draws on a lot of that. And so on the one hand, I would love to continue this project. On the other hand, I get very, very tired when I think about it because he does so much after this. He's in South Africa. He comes back. He's sort of, again, the center of the scientific community. He becomes the master of the mint. There's much more story to tell, and I would certainly love to do that one day. So we'll see.
Well, I'm just looking around, and I think the questions have come to. Oh, is there?
Okay, sorry. Well, thank you very much for that very interesting, enlightening talk. It's not an area that I have any knowledge of whatsoever. And I have to say it was very, very interesting to a non-expert. The question I wanted to ask is rather prosaic. It's how was the activities that John partook in financed? Was he financed by his own family wealth, or Did he have patrons?
Yeah, no, that's a great question. The short answer is he was independently wealthy through his family. What happened was William Herschel married a rich widow, Mary Pitt Herschel, who had quite an inheritance. And then William Herschel himself, through his work for the king and through building and selling large telescopes, had amassed a fairly significant fortune. And so when he passed away, when William Herschel died in 1822, John became independently wealthy, and for the most part didn't have to worry about money, at least during the period that I'm writing about. He's able to fund, for instance, he takes this grand tour. He's traveling for like 6 months throughout Italy and southern Italy and France and Germany. He marries, they end up having, I believe, 10 children. And it's a little bit unclear, and this would be work to do for other potential volumes. It's a little bit unclear later in his life, when he takes the position of Master of the Mint, if it was out of financial necessity, if that sort of played a factor into it. But for most of the period that I'm looking at, he was a man of independent means. Good question.
Thank you. Anyone else? I nearly missed that one, so I don't want to miss anyone else. I think this is okay. Sorry, one microphone was running out of battery, I think. Well, you've thrown, I mean, some of us know a bit about John Herschel, but you've thrown a lot more light on his life, and you've described the kind of currents that he had to swim either with or against at the time. And so this has been an excellent way of increasing our understanding, and we thank you very much. So
Thank you.
let's give you another round of applause, please.